Okay, so today is Thursday. So in class today, we have two different sections. Um, as you know, for the first 20 minutes of class before they go to lunch, they did their one pager. So what they did is they took their textbook, they we had it read to them from page 46 to 51. You should have wrote down your information from there. The one thing that I did show the class today that maybe you might want to put in your ISM book is this. When we talked about this before, we talked about the delta sign, which was the triangle sign, and T. When you see, guys, when y'all see the change in T, that means time final minus time initial. Right, guys? When we see change in X, that's change in position. That is position final minus position initial. Today, in our reading assignment, we saw a new symbol, which was the line above the variable, right? So if you see a line that's above the variable, that means average, okay? So what they did is they took the velocity, and what did they do with that? How do you find an average of something? You take those two, and you divide it by 2, right? If your velocity was 10 and 20, what was your average velocity? 10, right? Everybody good so far? Okay. So those people who are in the lab today, what they're doing back there and what y'all are going to be doing this afternoon when you go back there, there is 2 videos on today's assignment attachment. And what you're going to do is you're going to watch both those videos and finish your 4 square paper. Everything. We did a little bit of it yesterday back there, right? But today we're going to finish the rest of that. What else they're going to do is, if you'll hold your hand where you are on your page right now, and if you'll turn, please, to page number 53 in your textbook. Page 53 in your textbook is a study guide. It's like a one-pager for the whole chapter. So what they're going to be doing back there is they're going to go through and they're going to make sure, do I have these facts in my one-pagers? Because remember, you're having a test tomorrow. That test tomorrow will consist of you using your ISM book to help you. Everybody good? Now, when you get that finished, the last thing you'll have to do back there today is turn to the next page on 55. And do you see where it says mixed review? Mixed review. What that is that's a mixed problems of different sections, okay? So what you're going to do is you're going to try to do a couple of those. I don't want you to do all of them. I don't want you to spend hours on them, but I do want you to kind of make sure you kind of understand the concept. Is everybody good about what we're doing in rotation 2 today? So what we're doing in rotation 1 today is right now we're on page 48, and we are looking at the problem sample number 3. So if we look at problem sample number 3, it says the graph on the right describes a straight line motion of a student riding her skateboard along a smooth person-free with an average velocity. What is the average speed? Here we go again, where we're using this, right? V with the funny looking line on top. Okay? So we're looking for velocity average. So to be able to solve this, we have a formula that you should have written down. The average velocity is the change in position over the change in time. Okay, everybody? So when we're talking about average velocity, we're talking about change in position over the change in time. So what they did here is they looked at the graph. If you look at the graph, you see the graph goes all the way up to position 12, right, guys? That is your position final. If you look down at the very bottom where it starts, that is your position initial, and that is 0. Do you see where they got the 12 and the 0 from? And then the next thing they're going to do is they're going to do a change in time. So what you're going to do is you're going to go and you're going to take your line. You're going to go down. Do you see where they got 7 minutes from? They just took their finger and said 7 seconds, right? And then that was their time final minus their time initial, which is 0. Then they get their calculator. So go ahead and get your calculator out. And we're going to put this in the equation. Remember how to do a fraction on here. How do you do a fraction? Alpha y equal, right, guys? Okay, so let's turn it on. Let's do alpha y inner, or equal if you want to call it that. And now I have my fraction. Has everybody got their little line with the little dots on it? So what we're going to do is we're going to put this equation in. So we're going to do 12 minus 0. We're going to go down to the arrow key, and we're going to do 7 minus 0. And we're going to hit enter. What do you get? 12 over 7, right? Mm-hmm. So now what you're going to do is you're going to do 12 divided by 7. Hit enter. What do you get? 1.7. Does everybody see how we get it? Everybody good? When you put it in as a fraction and you're trying to do the subtraction of them, what happens is that you have to go just one more step where you've got to do a linear equation where you're doing the division sign. Is everybody good so far? Okay. So now what we're going to do is we're going to look at the problems. The way that they do this, the sample problems seem to always be the harder ones than it is what you're doing. So let's look at question number 27. Question number 27 says, the graph on figure 21 describes the motion of a cruise ship drifting slowly through the calm water. The position X direction along with the vertical axis is defined to be south. So I'm thinking we're looking at figure 21. So let me draw that. So here we have south. We have 0. We have time in seconds, right, guys? And 1, 2, 3, 4. And then over here, we got a -1 and a -2. Everybody agrees so far? Okay? So it says here, what is the ship's average speed? And what is the ship's average velocity? So what I want to do is I want to give you a couple seconds for you to figure that out. Okay. So what am I doing here? Change in velocity equals change in position over change in y-axis, right? Remember how we have our x and our y? Which one is our x and which one's our y? Right, guys? Is that right? Or is it opposite?
It's opposite.
There you go.
I think I did it. I did the other one.
Yep, we're all good, okay? So that makes sense, doesn't it? Right?
Mm.
Because what is on this axis here is time, right? Got it? Good so far. So my change in x, remember what I said. You have your x final minus your x initial, right, guys?
Mm-hmm.
You have your time final minus your time initial. We're doing rise over run, aren't we? Right? So where's our line? Our line goes from here down here, correct? Okay. Do you see where I got -1 from? How about 0? So what I did is you can choose any place on the line that you want. I chose this line right here. Okay? Rise over run. You understand now? You could have done 2, you could have done 3, you could do 4. It doesn't matter because we're going to do rise over run. Everybody good so far? So I did -1 was my final position. 0 was my initial position. And based on that, if I look, 3 seconds is where it stopped, right? And 0 seconds is where it started. Okay. Can you put your book over here for me, baby? Okay. So if I do 3 seconds, okay, and here, all right? So based on there, there's my -1, correct? There's my 0, right, ma'am? There's my 3, and there's my 0. You got it?
Yeah.
Okay. Guys, if you want to, if you have a pencil, if you want to mark on your book, okay, you can with a light pencil. If you did, what I did with her is I kind of did hers just like the one that's on the book. Mine's off because I'm just showing you the picture and mine's not direct. That is perfect. So if you don't see it, you let me know. Have a pencil and I'll show you. So for this one, down here, I'm doing 3 and 1. I'm doing this point right here. Well, I just chose any point. It doesn't matter. I personally showed that point. If you chose that point, you chose that point, you chose that point, it doesn't matter. The math's still going to be the same. So what I did is I just picked 3. All right, sir? This point right here. That's what I was doing. Kristen, do you understand what we're doing? We're on the textbook. Robert, do you understand? Okay. Do you understand that? Okay. All right, so that is where I'm finding my average velocity. So if we put it in the calculator, what do you get? So let's do that. Okay. What did y'all get? Yep. I got, are you ready? 0.3. Okay. Ma'am? Okay. 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 Robert?
Yeah.
Okay.
Wait, did you get 0.3 or negative?
I got -0.3.
Okay.
All right, guys, I'm going to show you on the calculator of mine so you can see it. Y is -0.3. Okay. What is my units for that?
30 meters?
Meters per second. Right, guys? Are we going to do, are we good with that? Everybody good? Question number 1A. Now what we got to do is we got to do 27B. What is the average velocity? Now, if we're doing velocity, we need to use this number, but we also have to use direction, right, guys? So it is 0.3 meters per second, but what direction are we going? Well, we're going here and there, but which way are we going? This is south, remember?
Oh, north.
North, right?
West?
Look, south is, we're talking about which way is it going? It's going that direction, correct?
Oh, yeah.
So it is north. That's hard to understand. That's the reason why I drew this, so I knew where south was. What's opposite of south? North. Is everybody good? So you have to put 0.3 meters north. Does everybody have everything so I can erase it?
Mhm.
You have to be in your ISM book, ma'am. We're doing practice problems. Okay, honey? Okay. Let's go to question number, the next one. I forget they're not in order of a number, is it?
28.
Yep. So, as she says, number 28, describe in words the cruise ship's motion in the previous problem. What's going on with the motion? What do you think? So it's asking you to describe the ship's motion in the previous problem. I put, go ahead, baby. I put the ship is moving 3.0 meters per second. The ship direction, motion, and its speed describes the ship's velocity. I will say that one more time. The ship is moving at 3.0 meters per second. The ship's direction of movement, motion, and its speed describes the ship's velocity. Does that make sense? Because I had the speed, right, guys, and direction. Yes, ma'am, I sure can. The ship's moving at 3.0 meters per second. The ship describes the motion, and its speed describes the ship's velocity. Number 29 says, what is the average velocity of an object that moves from 6.5 centimeters to 3.7 centimeters relative to the origin at 2.3 seconds? It's okay. Look, we're going to do our V again, right, guys? What was our formula that we used before? Change in position over change in time, right, guys? So let's look and see what this says. It says the average velocity of the object moves from 6.5 centimeters to 3.7. Okay? 6.5 centimeters is position final, right? Everybody agree? Okay? I like to put my variables down. My position initial is what? 3.7 centimeters. Okay? My time final, what is that?
2.3.
2.3 seconds. And what is my time initial? 0, right? They started, right? So it's 0. See how easy this is? The problem is trying to figure out where they were, right? So the only thing we have to do now, if you remember, change in X or change in position is position final minus position initial, right? Time final minus time initial. Right, guys? We know what that means. Only thing we got to do is just plug these numbers in. So our position final is 6.5 centimeters. We're going to subtract 3.7 centimeters. And we're going to take our 2.3 seconds minus 0 seconds. So let's get our calculator. So we're going to do alpha y inner, right, guys, to get our fraction. 6.5 subtract 3.7 over 2.3 subtract 0. And I'm going to hit my enter. What did you get? 1.217391304, right? So it's 1.2. Perfect. So my answer is 1.2 centimeters per second. Are we feeling more confident? Feeling better? Okay. Are you ready for the next one? Is there a second part to that one? Oh, nope, that's it. That's all in one. So now we're at 30. It says the graph on figure 22 represents the motion of a bicycle. What is the bicycle's average speed and what is the bicycle's velocity? Okay, so we're on figure 2 now. So here we are. This is a position time, right, guys? This is not a T-chart this time. This is actual graph, isn't it? So we have position over here. We have, oh, excuse me. We have 0, 5, 10, 15, and 20. Why are we using this kind instead of the other kind? Why are we using this one instead of the one that was in the figure before?
Because it's positive this time.
Correct. That's exactly right, Robert. There's no negative coordinates here, right? So it just kind of goes up, doesn't it? Kind of like that. So let's see what it says. We're trying to find the average speed and the average velocity. Where do we want to pick it from? Where do you want your line at?
10 and 15.
Okay. So we're going to do 10 and 15.
Like 13 and 20.
Okay. So 10 and 15, right?
Mm-hmm.
We good? We're going to do the exact same thing we did before, aren't we? How are we finding that?
The change of change.
Change up to this. I mean,
Yeah, change of position.
Right?
over time.
Correct? That's what we're doing. So now we have to have our final position is 10, right? So we chose one, didn't we? So position final is 10, and our initial position is 0. Okay? Now our time that we're going to do with this, we start at 0 again, right? Okay, so my time initial is 0, isn't it? What is my time final?
15.
15. Okay, we good so far? So position final is 10. What's our units that we have? It's in meters, right? Kilometers. Fantastic. Kilometers. So we have 10 kilometers, subtract 0 kilometers, right? And our time is in minutes. So where we are with time is 15, right? 15 minutes minus 0 minutes. Right, guys? So go ahead. Do your math. Hunter, you got about 2 more minutes back there and we're going to rotate. Okay, what did you get, man?
0.6.
Okay, 0.6. What's my answer? 0.6 what?
Kilometers per minute.
Kilometers per minute. All right. Do we have any kind of type of direction? I don't think we do we?
North, I'm
Well, the thing about it is, it doesn't tell us, and this doesn't tell us that, does it? Okay. So we're good. So what's the average velocity? Right. Exactly. Everybody good so far? 31. Describing the words. What is the words? What's happening here in our story? Oh, I'm so sorry. 37. Yeah, we did. Didn't we do 30? A and B? Average speed and average velocity. Oh, what's the average speed? We didn't do that, did we? We did the velocity. We did the velocity. We didn't do the speed. How do you change this? How do you figure out the speed?
For 30?
Mm-hmm, for 30. How do we do that?
So how do we figure out speed?
Yeah. So I put down both of them are the answers. So the average velocity we figured out, correct? And then the velocity and the speed is going to be the same, but like you said, it's in a positive direction. Okay? In a positive direction. So can we go into number 30? 1 now? What is 31? It's asking you to describe into words what's happening here. What is the bicyclist doing? At a constant speed in a positive direction. Sound good? Those of you in the back, if you would please take a wipe and wipe down your table and go ahead and start coming over here. Yes, sir.